Good morning everyone. My name is Oshotav Kaushal from Electronics and Communication branch of TIET. With the help of this video, me and my teammates will give you all an insight of a Capstone project, gift cryptography algorithm and its implementation using Verilog. Now my teammates will introduce themselves and will tell you all about this project and its working.
Good morning. My name is Hardeesh Singh and I am from 4EC3.
Hello, I am Varun Goyal and I am from 4EC3.
Hello everyone, my name is Rohan Kapoor and I am from the Electronics and Communication Engineering branch.
Hello everyone, this is Bhaskar Bliss from Electronics and Communication Engineering branch here in TIIT Patiala. I am going to introduce and demonstrate to you our final year capstone project is design and implementation of gift lightweight cryptography algorithm using Verilog HDL. This project was completed under the mentorship of Dr. Manu Bansal and Dr. Anil Singh from ECE department here in TIIT Patiala. Starting with cryptography, cryptography is the technique of securing information and communication through the use of codes so that only the person for whom the information is intended to can understand and process it. We use techniques that are obtained from mathematical concepts and set of rule-based calculations known as algorithms to convert information in a form that makes it hard to decode and hence provide the protection required for its transmission. Some of the algorithms in use are AES, DES, and RSA in applications like digital document signatures, identity verification systems, and digital transactions. The algorithms like DES and RSA are very resource intensive and hence unsuitable for usage in smaller scale applications which have limited electronic resources and more elementary requirements for encryption like RFID cards, location trackers, healthcare devices, etc. Therefore, lightweight algorithms like present and gift have been developed and brought into usage. Present algorithm was introduced in 2007 and gift algorithm was introduced in 2017 as its advancement in terms of efficiency, resource usage, and security provided. This project involves the design and implementation of gift lightweight cryptography algorithm using Verilog HDL. As a future prospect, the findings can be utilized into implementation of this algorithm on a FPGA board and eventually development of an integrated chip based on the same. The motivation behind this project is to facilitate indigenous production of cryptographic chips to lower the cost of the devices using them. Here we can see the diagrammatic representation of gift algorithm and we can observe the various processes involved in each round. This algorithm has 28 rounds of encryption followed by 28 rounds of decryption. Moving on, we can see the system architecture of a gift algorithm single round of encryption. The algorithm takes a 64-bit input data and a 64-bit encryption key as the input. The data is passed to the substitution box where the bits of the data are substituted with some other bit as per the table shown. The output data of this step is passed to permutation box where the positions of the bits are interchanged as per the table shown here. On the key side of things, a 32-bit round key, that is two 16-bit keys, are extracted from the MSB side of the input key. These keys are then XORed with the data obtained from P-box at specific locations as defined by the equation here. This data is then forwarded where the predefined 6-bit round constants are XORed with it at specific bit locations as defined. The final data is the ciphertext of first round and forwarded as the input data to the second round. On the key side, the input key is updated as per the procedure shown here and eventually becomes the input key for the second round. The entire process repeats itself for 28 rounds where we finally get our ciphertext and key. This ciphertext is then transmitted to the receiver where they can perform 28 rounds of decryption, which is essentially inverse of the encryption process to decode the input message. Welcome to the code and implementation of gift algorithm on Xilinx HiC software using Verilog HDL. Here we can see the input and output signals for various data and key, load signals to initiate encryption and decryption process, and a clock signal. Moving on, here are some wires and registers used to store the interim data and key values. Eventually, in the encryption process, we can see the various modules like S-box, P-box, and round key box being initiated one by one where the data is transferred from one's output to another's input. We can also see the key update step in line 70 of the code. Moving on, here are some sequential conditional statements that are required to run the code as per our requirement. At last, the final data and key are transferred to the decryption algorithm where the inverse process takes place to extract the initial input data. The decryption process of the algorithm is as shown. After this, we will show you the signal waveform output. This is the output signal waveform of the Verilog implementation of gift cryptography algorithm. As you can see here, the input 64-bit data to our code is FEDCBA 98765432110, and the 128-bit input key is FEDCBA down to 0 and FEDCBA down to 0 again. After 28 rounds of encryption, we can see the input data has been encrypted into a different form represented by 62621248D6E2ED51. This encrypted data is known as the ciphertext, which is transmitted through the transmission channel and to the receiver, and where it is decrypted into its original form again, as shown here. After 28 rounds of decryption, we get the data which was inputted as FEDCBA 98765432110. Thank you for joining this presentation. I hope you enjoyed and understood the concept that we tried to implement in this capstone project.